Hello, my name is Victor, and in this video I will present how I implemented a deterministic finite automaton in C. My idea was that this automaton could recognize identifiers, numerical constants, and strings in Pascal. So let's see how the process of this implementation was done. So the first thing I did was try to understand the problem. Looking in books or on the internet, I found that Pascal numerical constant syntax is something like that will contain an optional symbol that is plus or minus. Then it will have a sequence of numbers, numerical characters. So it can be here 72, it can be 0, it can be 197, any character is with 1000, right? Any number. And here it's an optional dot n that will represent the floating part, so here will be dot 72, and finally an exponential part of the syntax that will, with this all together, we will have something like minus 2.72 e exponential 10, and that means something like that will mean 272 at 10. Okay, so this is the syntax for numerical constants. The syntax for identifiers is something that will have an initial character that can be any alphabetical character. Okay, the C is for alphabetical character, so it can be A, B, anything. Then we'll have 0 or more of those symbols that is or another alphabetical character, or a numerical character, or an underline. So with the syntax, we are telling that with this regular expression, okay, we are telling that our identifier can be something like A underline 72, ABC, just A. Okay, this is the regular expression for identifiers. And finally, the regular expression for strings is that, so we will have an initial single quote, then we have this that is 0 or more of any character except a single quote or a double quote. So here we will have, for example, my name, then double quote, and then we finally have the single quote that will end the string. Okay, this was the first step for me to understand what I want to generate with my algorithm. Now that we know what we expected our automaton to answer, we need to represent it, and I choose a graph representation. So for example, just for numerical constants, my automaton would be like something like that. So here we have an initial state, and it will receive here n represents numerical character. Okay, so it can be any numerical character, and S means for the plus or minus symbol. So for example, here it can receive a number like 8, and it will come through here. Here is a S2 is a final state. Okay, so it can just finish there, so you have the 8 here, or it can go through all the graph to another final state. So if, for example, imagine the input for this automaton is 82.5, right? So first it receive 8, then here it will receive the 2, so it is now in S2 state. Then it will receive the dot, so it will come through here, and now it in S3 it will receive the 5 here, and now it finishes because and the answer is yes because it is in a final state. Okay, now let's imagine we receive 8a, for example. So here we start the initial state, and then we receives 8, and now we receives a, but there is no transition for alphabetical character, just for numerical characters. So there is no transition and we still have input, the answer will be no. Okay, now let's go to our other part of our automaton. So in identifier, we will have an alphabetic character. So we start in initial state, and any alphabetical character will send it to state 8 here. And now it can accept alphabetical characters or numerical characters or underline. So if we receive, for example, V underline 7I, okay? So starting in S0, we receives V, transition in here, and then we receive this underline, so it will transition through here. Then we receive the 7, transitioning through here. Then we receive the I, transition through here. And now we finished parsing our input, and it's in a final state, so answer is yes. Okay. So, and the final part is for strings. And here C represents any character except the single quote. So a string can be something like Victor here. So we start receiving the single quote, and now we will parse the Victor part of our string. So we will just transition here 6 times, and then finally we will have the last single quote going to the final state. Okay, so now we have what we want to build, what our automaton will look like. And now we can go to the C part. Here I am executing the main.o program, that is my automaton. So for example, if I input this text, it will say it's an identifier. If I input a number, it will say a numerical constant. If I input the string formatted like before, double quotes inside, quoted, double quote again, another text, it will say it's a string. And that's what we expected, but if I insert another thing, it will tell it's not recognized. Alright, and if I type exit, it will end. So let's see how it was implemented. So here we have the data structure we needed. I needed to represent a graph, and I did this using those two structs. That is, the state representing the node, and the transition representing the edge. The state has a name, used this for debugging purposes. For example, using a breakpoint, I could know in which state I was without needing to know the memory address. So I just, for that, I used the name. Is and tell us if this state is a final state. Here we have the list of transitions. This state has a max of 255. It's the max transition above. And transitions count tell us exactly how transitions it has. As max is 255, we could have 10 or 2. So this is what this variable tells us. And transition has a value that is the characters that will send us from a state to another state. It could be, it is represented by a string, so this means that if I'm in state A and I receive 1 or 2 or 3 or 5, I will be sent to the next state. So below we have this, that is all the states I will use. You can see here I use letter E, but those are the S0, S1, S3 from our sketch. And below we will have our initializers, that are the functions we use to start or fill our graph or state machine. That is our automaton. So first, init states. We initialize the E0, E1 without any transition. Init a state is a function that's called only in init state that will initialize each one. And add transition will add a transition from state to another state with the value, the characters in the string. So let's take a look at init state first. Here, because of I created init a state, it's really legible here. So I initialize the state E0, named as E0, and it's not a final state. I do the same for every other state, right? And below we can see that now I will add the transitions we need. So here I just gave a name for the n we use there. The names I tried to keep the same of our sketch. So here is the transitions, and represents that all transitions that will send from a state to another when for numerical characters. The S is our symbols plus minus E dot. I divided this for according to what we are trying to get. So numerical constants, and here I added all transitions from our first state machine, our first automaton we sketched before. Those are the transitions we needed. Identifiers, I did the same here. Those are the alphabetical characters and the transitions we had before. An important thing here is to realize that the E0 is the same for identifiers or for numerical constants. I kind of merged those three automaton in one. So that's the same E0. And for string, what I do is have the string, what I call the string transition, that is our single quote. And here nabs is our C before, and that represented our any character except the single quote. I used an aux function for that I created, that just use the ask table to get all characters except the single quote. This was important because all other characters is not only the alphabetical and symbols like asterisk, but it has space, it has new lines and these things. Actually, I don't know exactly how Pascal handles new lines. It may not be considered inside a string, but here I consider that. Init I state, what I do is get the name, the is and created this here using malloc for transitions, using that max transitions again, and add transition. Basically, we just add a new transition. Okay, from state transitions, a new. The transition count here used to know where exactly in transitions list I will add the new transition. It's missing a test here. We should use a test like if transitions. And see, we have this. If transitions max transitions is less equal than from state transition count, return, for example, because it can't add, it can go add a new transition if it's already to have, it already has 255, because it will be an overflow for that data. Okay, here is the algorithm itself. But before explaining this, let me go back to the main, okay, our primary function. What I do here is init the states, we just saw that, some printfs, and I have this while loop that if while user doesn't type exit, it will keep asking an input. That's what it does here. I used this buffer and fget because if I use this scanf, it would not accept the blank space. Then I use get final state, that is the other function we will saw next. And here I use this if analysis to know if the final state is E2, E4, or E7, it is a numerical constant. If it's E8, it's an identifier, or if it's E10, it's a string. Otherwise, it is not recognized. Get final state is actually our algorithm itself. The first thing we will have is the input, that is the typed value user sent. The state will be the initial state. In our case, it's E0 or S0. Here we have this input index that represents the index we use to parse our input. And C is the character we are parsing at the moment. And current state will keep the current state we are in our automaton during our parsing. So this loop here, all it does is parse it through all characters in string, and for each transition for our current state, so we are in E0, for example, and we have a transition from E0 to E1 for any number. If C here is a character number, or we verify this here, so we will go to the next state, in this case for E1, and we will loop again for the next character user inputted. If it's not the case, there is a transition for the inputted character, it will detect it here, okay, and we return 0. That's basically as we return a memory address, a pointer for a state, returning 0 we return null, basically. And then otherwise, if you found a transition for a new state, I will get the next character and do the loop again. If we found this \0 character, meaning we parsed all string, we return the current state that could be or not a final state. Okay, and so in main we just used our algorithm, and here we verifies if it's a final state. The reason I'm not using isAnd here is because my automaton, I want to know if it's a numerical constant or an identifier or a string. The issue is that I implemented only one automaton for that. Ideally, I would need 3 automaton for this difference, but if I wanted to know if it is a numerical constant, an identifier, or a string, and I don't care which one it is, I just want to know if it's one of those, then I could use the final state isAnd. Okay, now I know is one of those things, and I would get the yes or no. Okay, that is it. I really hope you enjoyed. My explanation may have been a little confused, but I will, in the description, I will put my GitHub link for this project, and you are invited to comment, make questions, and that's it for now. Thank you for watching. See you.